Alright, Chesney, story time. So this is a story about a 5F2 with a smoking resistor. What to do? Sent to D-Lab in the nick of time, repaired in a jiffy with a bottle of wine. Here we go. I have a vintage Princeton that was sent to me from a guy in Hawaii. I told him that I'd be working on this tonight, so maybe he'll actually Skype in. So he says he got this thing in Hollywood, I'm assuming in California. It says GIT 81, maybe in 1981. It had a master volume or something which had to be removed. It had a 10-inch speaker which he's also changed. The output transformer has also been changed. It worked for quite some time and then went up in a ball of smoke. So we're going to give this jobber a little inspection. Yeah, I said jobber. There's a lot of little post-it notes in here. So my camera work might not be the best, but let's get it up here so you can see the inside of it. Okay. Whoops. You can see it's pretty vintage. A lot of little cobwebs in there. Little post-it notes. There's the front panel, a little bit rusty. Here's the top of it with the new output transformer. It appears to be the original power transformer. He wrote me and said that a resistoroid in here went up in a ball of fire. He actually has it tagged. Looks like it's the 22K resistor which feeds the preamp section. So the first thing that I want to do is obviously get the post-it notes out. And then we're going to carefully power it up with no tubes installed. I want to make sure that the power transformer is okay. Then we'll put it in the rectifier tube, give it another test, one step at a time. The other thing I just noticed, this socket here for the 6V6 has been replaced. Isn't that lovely? So I actually have some of the original Fender type that mount from the bottom of the chassis. We'll install that after I determine what's wrong with the amp. One thing I noticed right off the bat that seemed strange is this is a screen resistor. That should be like a 10K, not a 22K. Okay, and that's fed into another 22K which goes to the preamp section. So that guy shouldn't be there. The 470 ohm resistor right there feeding the cathode of the 6V6 looks like he's been a little warm, but he's not torched. So I think the first thing I'm going to do is get that 22K out of there, put in a 10K as per the print I believe, and then we'll bring this guy up slow. There's also some craziness going on up here. This blue lead, I don't know if you can see, but that blue lead is actually touching pins 8 and 1, so they're kind of shorted out. That may be what's causing a lot of the issues here. Anyway, let's go ahead and get a 10K in here, put in the rectifier tube, see if the power supplies come up. Alright, here we go. Get that 22K out of there. I don't know how anybody put a 22K in to begin with. So a lot of times this old solder won't move unless you apply a little more solder to kind of wet the tip of your iron, get that heat moving. There's all kinds of solder here, and this guy was just like tacked in there. Okay, so I've got a 10K. Get it installed. Filter caps appear to be okay. We do got some little bubbles on the positive side. I'm not going to worry about that at this point, but I'm guessing they could probably stand to be changed. Alright, so I have the new 10K resistor installed. So at this point, I'm just going to check the filter caps Make sure we don't have any shorts, because something smoked that resistor, right? So down the cap line, I show no shorts. Here's the ground sides. Let's see if they're okay. Whoops. Well, I'm having some issues with my leads tonight. There we go. Make sure they're all going to ground. They are. Here is that cathode resistor, which is a 470 ohm resistoroid. He's up to about 570 ohms. It's got this other electrolytic down here on the preamp side. Looks okay. I do not see any direct shorts. So the problem could have been with one of his output tubes. Anyway, we'll put in the tubes, because remember, I did just clear a short right here, which is actually the output transformer lead going to the 6V6. So this is kind of odd too. Very odd. So yeah, pin 8 goes to the 470, but pins 1 and 2 are tied to ground. Okay, well that makes sense because that's a filament supply. Okay, but I did have a short from 3 to 2, which definitely could have caused this whole problem. And there, as you can see, the insulation is back quite a ways on that blue wire, so it could definitely short. Okay, so this thing may already be fixed, but there's a lot of cleanup work to do. So let's get the tubes in. Alright, all the tubes are installed. Now these are his tubes, okay? So they may have issues, I'm not sure. I've got my meter set up, DC volts, got my ground lead connected. What I'm going to do is bring this guy up slowly on the variac. We're going to look for like fire and smoke, okay? Which I'm sure there won't be. So right now I'm at 50 volts and my current is like next to nothing. Good sign. Let's see what we got in here. So there's about 56 volts. Let's bring it up a little more. That's 70 volts input. So you got about 228 there. There's 80 volts input. Let's take a look at the cathode resistor. Oh, you see that? Smoke-a-ramus. Something's smoking. What is smoking? Got smoke coming from somewhere. I didn't catch it. I wonder. I turned it down. Let's go to the other side of that screen resistor and bring it back up again slowly. This is the beauty of a variac. Okay. Okay, here we go again. Ah, look at there. So I got 160, 200 volts on one side of the resistor, 0 on the other. So guess what? Probably have a screen short. Let's pull out the 6V6. See what happens now. Go into that input. It's about 180 something volts. What do we got over here? We still got nothing. So either I baked my 10K resistor that fast, or we've got a direct short on that cap. That's interesting. Pretty cool doing this live, huh? Alright, let's go to ohms. I thought I just checked this. Okay. So there's my chassis. So we got continuity. There's one side of the 10K. Here's the other side. Look at there. I do have a direct short. I thought I checked that. What's wrong with me? Okay, so we have a short off of the 10K resistor, which is the screen circuit. Goes up here. Oh yeah, and this wire is like all crispy crittered. That's strange. Still have a short though. It's strange that the wire is cooked, but yet I got the tube out. So if the tube was a short, it would have been cleared, right? We still have a direct short on the screen pin to ground. It could be the tube socket, or it could be this capacitor. So let's lift out the cap. Don't really need a dummy load at this point, do we? Alright, so I lifted this cap, which is a 16 microfarad cap. There is a little bubble right there. So if we go back to the 10K, guess what? No short. Let's go to the cap. Bam! This cap is directly shorted. Okay, we found the culprit. Shorted capacitor. So in this case, I need to change all of them, because if one of them is in that condition, they're all right behind it. The stock caps are 16 microfarad at 500 volts. I'm going to replace them with these F&T 22 microfarad at 500 volt caps. I use these in all Fender amp repairs. The amp will know absolutely no difference between the 16 or the 22. You'll just get a little bit better filtering, okay? So don't let that alarm you if you need to do this to your amp. The 22s are fine, okay? So I've pulled out all 4 of those old filter caps. Take a look at the positive side, okay? See all that cracking? See the little bulge there? A lot of bulges. These things have seen better days. Got all the new F&T caps installed. So let's bring her back up. 6v6 back in there. Get my dummy load hooked up. Let's see if she comes up and no smoke this time. Alrighty. Meter back at DC volts. Reacts at 0. Plug him in. Bring her up. Same deal. Okay. So let's look. The high voltage coming off of the rectifier tube. Here she comes. About 60 volts input. So you see we got 200 volts on that side of the 10K, and look at there. Now we got 220 volts on the other side. Short's cleared. I bet you the amp will work now. Bring her up a little higher. Let's check that cathode tube voltage there. There she is. About 10 volts. I'm at 70 volts input. So I'm sure the amp is fixed. Here we go. Power it up. I have an audio generator going to the input. Look at there. Whoa, megaton of gain. Volume control is doing like nothing. So we got other issues, but the amp is powering up and it's not puffing out smoke. Good sign. So for the heck of it, let's give the old volume control a little squirt of deoxit. See if we got an issue there. Check the pot real quick. Make sure it's alive. Inside the ground. Yep, the pot is working. So I don't know why we got full volume unless it's miswired. Dog just came in panting. He was out running around, probably chasing bunnies.
Never saw one.
Yep, so here we go again. Just cleaned the pot. Looks like that was the problem. Nope. Look at there. So, volume pot does nothing. Time to investigate. And I believe I found it. This little cap here is right against the chassis. The terminals on the volume pot are kind of squashed in. Probably happened in shipping. On an initial inspection, I probably should have cut that. Okay, let's try it again. Really don't need the meter at this point. Scope is still connected. Let's see if that cleared that fault. That's a negatory. Interesting. Okay. Huh. This is a good one. Well, it appears as though the volume pot is actually working. And it looks like it's wired correctly. So now I'm wondering, is that the signal? Or is that maybe an oscillation that the amp itself is generating? So here we go. No signal applied. Let's see if it still goes nutso. Yep. Look at there. So it's not the input, it's not the volume control. Something is oscillating in the amp. I did find a bad solder connection. Let's see if that cleared the fault. Nope. Still there. Now, let's see if this corrects it. Pulled the 12AX7. So it could be a flaky 12AX7 doing this, or something in that associated circuitry. So let's put in another 12AX7. So I removed the Electro Harmonix 12AX7, put in a Sovtech. See what happens. Remember, you're seeing this when I see it. Oh! Nope, it's not that. So we got something else going on. This is interesting. So I believe the next step would be to check all the components in the preamp section. We got a couple 100K resistors, a little 1.5K. Got this electrolytic here that's stock. We all know what happens to those. So I've seen this type of problem in the past, and sometimes it's a feedback issue. So let's, for the heck of it, lift Mr. Feedback Resistor and see if that clears the problem. And if it does, it could be a problem with the phasing of that new output transformer that I showed you. Okay. So feedback resistor's pulled up. Here we go. See if the problem goes away. Yep. See, they're gone. The amp's not working, one of the two. So I have my audio generator. Interesting. Well, the feedback's gone, but I'm not getting much of anything through that 12AX7. So we got more issues. So we got there. Oh, there she is. We got a bad connection there. So that's coming off the preamp tube through Mr. Volume Control. Let's see what we got here. Yep. So we got a signal. Question is why? Oh, there it is. Once again, just bad connection. So look there. That tone control is dirty. Give him a little master blast. Okay. Over there. The amp is working. So it is a feedback problem. Looky there. We're getting there. So to see if the feedback would be corrected, I reversed the blue and brown leads from this new output transformer going to the output tube. Amp is fired up. You see she's clean. That oscillation is not there, and the feedback resistor is hooked back up. Okay. Here's the signal applied, and there she is. So it was a phasing issue on the output transformer causing that oscillation. So let's do some cleanup on this amp. First thing I'm going to replace is this 6V6 tube socket, which is mounted on the wrong side of the chassis. It should look like this. You can also see it's pretty worn. It's bent. Needs to be replaced, and I just happen to have an old stock replacement that's going to go in there. Then we have to clean up the AC line. You can see we've got some splices hanging in midair. Still has a death cap, needs to go away. There's a paper cap on the tone circuit. This guy here is more than likely dried up. So we're going to change the caps, clean things up, and I'm going to check this 470 ohm resistor. We'll check for the current through the output tube, make sure it's at a safe level so that the 6V6 survives. I have the new 6V6 octal socket installed, wired up, and I replaced the little 25 microfarad cap on the preamp input. So next I'd like to fire this thing up, make sure everything is alive and well, and then we'll take care of this mess. Alright, here is the initial power up of the amp after replacement of that octal socket. And what I want to do at this point is just see what the current is flowing through the 6V6. So back in the day when they designed these, the AC voltage coming to your house was about 110 to 115 volts. Now it's up around 123 or so, which raises the high voltage in your amps. So the 470 ohm cathode resistor that they designed these around is probably too low, and you're going to have too much current flowing through the 6V6. If you watch some of my other videos, you'll see I bumped these up between 750 to 1000 ohms. Okay, so we are going to check that current. I have a little dummy load resistor here simulating the speaker and making the output transformer happy. And you see it's only a 1 watt resistor. That's okay, because I'm not going to be cranking up the amp and applying the signal. It's just to make the impedance proper for this test. I have a current meter hooked up right here, watching the current through the 470 ohm resistor through the 6V6 back to the plate voltage, which we'll monitor here. Alright, let's plug it in. Here we go. Power is applied. Here goes your high voltage. See there? About 480 volts unloaded, and now the tube's pulling current. You can see that over here. That's why you need to put 500 volt caps in these amps. Okay, don't do a 450, because over time they're going to pop. Alright, she's idling at around, let's just say 400 volts, about 42 milliamps of current. So if we take our pocket calculator, say 0.042 times 400, it's about 17 watts of dissipation. The 6V6 wants around 12. So we are going to change the 470 ohm resistor. Alright, so I subbed in a 750 ohm resistor. It's plug it in and see what the current does. Just warming up. There's my high voltage. Here comes the current. Alright, call that 35 mils. Do the same thing. Now I'm at about 14 watts. Okay, so you can play with this value of resistance to get the current that you want. If you run it too cold, you won't get that nice bark out of the 6V6. So 1K could possibly be a good value, or even a 820 ohm. Alright, mission complete. Cleaned up that AC line input. The neutral now is soldered direct to one lead of the power transformer. The hot goes through the fuse holder, looping over to the power switch. And of course we have all the replacement parts, which are here, our fallen soldiers, filter caps, some other caps, bias resistor, and of course that ratty tube socket. Well, here we go, final test. And for the fun of it, I thought, you know what? I'm going to pull out this newly manufactured 6V6 and put in one that's NOS with dust, right? Using the D-Lab audio test set as my load and interface to the oscilloscope. Got an audio generator up there. Let's crank her up, see what we got. There she is. Nice sine wave. There's my tone control. So it looks like the amp is off and running. Vintage amp, ready to go again. So what a happy ending for that Fender 5F2 amplifier. It's going back to Hawaii to be enjoyed for years to come. Just another of the never-ending repair stories here at D-Lab Electronics. We'll see you again.